Hi all. Today's topic is with respect to SOAFEE. So SOAFEE stands for Scalable Open Architecture for the Embedded Edge. It's a community where they speak about how to incorporate the cloud technologies on the vehicle. Okay, so if you see the first slide, so here the industry collaboration is across the entire automotive ecosystem completely from end to end. Say it is the OEM, the Tier 1 suppliers, the silicon vendors, all the key partners, software companies, everything. Okay. So why do these guys even need to collaborate? Like, what do they gain out of it, and why can't any company do it? Do the transfer of the cloud native technologies from the cloud onto the device. So the a main aim of SOAFEE is to have a hardware agnostic solution so that the vehicle softwares can be deployed seamlessly across any kind of hardware. So if you see this slide, so here the applications are the general ADAS, in-vehicle infotainment, which is IVI, autonomy, vehicle functionalities, many things. Okay, and the last layer, which is the hardware layer. So the hardware layer could be GPU, CPU, it could be safety CPU, or it could be anything. So the middle layer is SOAFEE, where they are trying to bring some open standards and they are trying to bring out some best practices so that irrespective of what hardware you are using, the softwares can be deployed seamlessly, keeping in mind that the hardware requirements are met. So the automotive industry is quite well known for a lot of coupling between the hardware and the software, because when the OEMs procure something from the Tier 1 suppliers or any suppliers as such, the software which the supplier provides is very much hardly coupled to the hardware. The software which is provided by him is coupled to the hardware which he also ships. The business model in the automotive industry till now is get the hardware from a supplier and software is kind of a free. But with the advent of high performance computers and all, this particular business model might not work in almost all the cases, because the idea is to shift all the functionalities which are below SLC, means the SLA, SLB, and QM will be shifted to the high performance computers, and for the time being, SLC and SLD will be remaining as such. Mostly, it could be like steering, braking, and other very safety critical aspects. So in that case, bringing this particular software packages which these suppliers are providing along with their proprietary hardware, how do you make that particular software run on a hardware which is high performance computer, which has to be shared across different functionalities, because the high performance computer is not specifically targeted to run only the infotainment system. It is targeted to run the infotainment system. It is targeted to run maybe the rear light functionalities, the parking cameras, and all these functionalities are expected to run as containers. So how do you kind of create some best practices so that a functionality which has been developed, say Bosch has developed something with respect to rear view camera functionality. Now they are selling it to Toyota, and say Ford also wants something similar. So how do they translate? How do they kind of move this functionality to Ford seamlessly? And what are the best practices which can be followed? So SOAFEE is with respect to all this. So the main question comes is, why can't a single company directly define with respect to how to do it? So the reason why that is not so easy is the all the companies should come together, or this motto of SOAFEE is as such: use collective intelligence to deliver the right solution to the technical challenges in a safety critical industry. So what this means is, one company or one organization as such cannot provide an end-to-end solution, because you're dealing with a safety critical system and anything anywhere can go wrong, and you cannot own the end-to-end value chain from the functionalities till the deployment to a car. So for that reason, all of these companies, so this company consists of lot of, as I have shown in the earlier slide, the OEMs, the suppliers, silicon providers, everyone, they have collectively come together to address these challenges. So what are some of the few challenges which we can think of? So one is the cloud technologies. The first point. The first point is safety certification of cloud technologies. What this means is the cloud technologies as such, say Kubernetes or Docker or Podman or any of these, as an example, they are written in the language Go. And Go is a language which is mostly followed in cloud. But when you're trying to bring these kind of maybe if you want to try run Kubernetes on the hardware, say in a vehicle, the problem in a vehicle is languages like Rust or C++ are much more preferred in the automotive use cases because due to memory safety requirements and determinism, which the cloud native language like Go might not be able to deliver to this standard. So in this case, you might have to entirely rewrite the entire Kubernetes or Docker from Go to C++ or Rust. Now, it will be extremely hard for one organization to do it, and even if they do it, with respect to the community, the support, the testability on various what to say across multiple scenarios is something which is better. It can be achieved better if at all it is being done as a group rather than an organization. Second, second requirement is the startup time. So, if we are in an ideal world, if at all we envision that all these multiple functionalities which are running in a car, it could be your brake, steering, or whatever. If all of these are made into microservices and they have to run, then you will be having at least 100 microservices which has to run within a second or two when you turn on the car. If that has to happen, basically it is like 10 to 50 milliseconds per container to start up and to be ready. The current cloud technologies which are out there, they don't have this level of what do you say? Yeah, they don't have this level of performance. That is another reason why the industry must come together to fix these issues. Third thing is with respect to the scheduling and the priority handling, which basically happens in the uh, cars as such. So you do have some fast tasks, you do have some lazy tasks, and you do have an ATOS which is keeping track of all of this and maintaining the scheduling and all. Now these cannot be compromised in automotive. So the containers which are running as such should be able to meet these requirements with respect to the execution time. So there is even a latency time also. Say a signal goes from the sensor to the actuator, and it has to travel through to the ECU and all. Then basically there is an acceptable latency time, and the latency cannot cross this time because if it crosses, then it might lead to an accident. So in these scenarios, how do we make sure that the requirements of timings are taken care of? So these are many of the challenges which are ahead of the automotive industry, which has to be fixed, and only then they can think of releasing or creating a vehicle which is fully SDV, where the cloud technologies are very much in line with the requirements of the automotive industry, because the cloud technology capability as such as of now is not up to that mark. So this is the reason for the collaboration. That is the reason why all of them have come together under the organization called SOAFEE. So SOAFEE has released the first blueprint of their architecture. So this is the first blueprint of their architecture, where here you can see they are talking about high compute CPUs, high compute GPUs, and on the bottom right hand section there is a safety CPU. So all the safety critical aspects are being taken care in the safety CPU, which is physically separated from the high compute CPUs and non-safety CPUs. And you have the various hypervisors, RTOS, OS, normal OS, and many such uh, yeah, and many such things, which are uh, part of this particular SOAFEE's first blueprint. So this is a short idea with respect to what SOAFEE is. I will provide the important links in the description of this video. Please do have a look if at all you are interested. Thank you for your time.